Hey everybody, welcome. I'm Mike Hirschberg. I'm the director of AHS. So for those of you who were not here during the week, you missed a fantastic technical conference, lots of great technical papers and higher-level programmatic talks and the banquet last night. So it's been an exciting week so far, and we're going to cover some of the different aspects of the promise and progress of electric vertical flight, transformative vertical flight. We started using transformative vertical flight several years ago when it wasn't clear that things were going to be mainly electric that we were talking about. So when things were still pretty open. And we've done a series of workshops, as Chris mentioned. This is our 5th annual workshop, and we've done a lot of this stuff with AIAA and SAE and NASA and ASTM and several of the other professional societies. All right, next chart. Do I have is this a remote here? Looks like a remote. Hey, look at that. All right, so how many people are not a member of AHS or just became a member of AHS? Can I see a show of hands? Okay, so there's a few people here that's worth going through this. So, we were founded in 1943, basically about the same, within a month of when Sikorsky got the first contract for the first American helicopter. And at that time, they, with a lot of other researchers, companies, government, said, we really need to have a society for helicopters, this new vertical flight industry. So there weren't any other helicopter societies or association at the time. We were American Helicopter Society as we were originally founded, and now actually this month is 75 years since the first get-together and kind of some of the first discussions on whether to found AHS. And from the very beginning, it was more than just helicopters and more than just American. So the name's been a bit of a misnomer since the beginning. But everything we do everything from micro air vehicles, quadcopters, helicopters, advanced rotorcraft, electric VTOL, STOVL, and we've had a long history of engaging on technical and other important issues regarding vertical flight. So we're a nonprofit educational technical society, so we're all about expanding knowledge and making advancing vertical flight. We do lobbying and advocacy, and it's really about educating you guys here over the next couple of days, and obviously educating our future leaders of vertical flight. So as I mentioned, we have a proud history of advocacy and support. We worked with NASA and the Army and the Air Force and had the full-scale wind tunnels transferred from NASA to DoD when they decided that NASA couldn't support it anymore. There's a lot of joint NASA and Army, the Joint Office, Vertical Lift Research Centers of Excellence, National Rotorcraft Technology Center, Vertical Lift Consortium. We had a hand in an important role in establishing and helping all these go over the years. The reason I'm here today is because in the 1990s I was working in the Joint Strike Fighter, or JAST program office at the time, and there was a huge outreach from AHS to support this crazy idea of having one aircraft or one basic aircraft concept and having one of them have vertical flight capability. So we had JSF days at our annual forum every year from I think it was 95 through about 2001 through the end of the competition. So AHS provided major support to the original JSF program. Same thing with the V-22 Osprey. There's probably been no greater supporter and booster and promoter of tiltrotor technology besides the Marine Corps and Bell and Boeing. Probably no greater supporter than AHS over the years. And both of those programs, V-22 and F-35, they're controversial because it's been complicated and expensive and it's been very difficult. But those are two transformative capabilities that are now fielded. The last actually 10 years, AHS has been promoting and supporting future vertical lift in the Joint Multi-Role Program. So we worked with the Congressional Rotorcraft Caucus in the early 2000s to help get congressional direction telling DoD to start a FVL program, and have been supporting that vehemently over the years, and we've been responsible for getting about $40 million of additional funding from Congress for the FVL program. And so now here we are with eVTOL, so we have a fantastic record of success. Of course, I didn't talk about some of the ones that didn't actually make it, but this is what we do. We exist to advance vertical flight. So we're all in on electric and hybrid electric VTOL aircraft. So this is a workshop. We're actually probably going to change the name because Transformative Vertical Flight Workshop is a little bit of a mouthful and not immediately obvious to it. So we're thinking that the next year it'll be something more like the Electric VTOL Aircraft Symposium or something. We've started a new. We're starting. We've had a committee, the Transformative Vertical Flight Committee, and that'll now be the Electric VTOL Committee. And Dr. ABAB Database, stand up, raise your hand. So he's going to be leading our efforts, and we have a lot of exciting plans. Next January in Phoenix. We have our biennial, what's sometimes called unmanned rotorcraft, sometimes called autonomous VTOL, or other combinations of those words, but basically our autonomous VTOL conference next January in Phoenix. So that'll be the 6th annual Electric VTOL Symposium in conjunction with that. And then we're kind of talking now about coming back here, but to Mountain View, so we can get bigger rooms and have more people and more expansive exploration of this exciting area. We've been working with NASA's with NARI. Where's Mike Dudley? Is Mike Dudley here? You will be here. So NASA, NARI is what? NASA
Aeronautics Research
Initiative? Aeronautics Research Institute. We'll go with that. So you'll hear about that a little bit later, but Mike Dudley and his team has been really fantastic in supporting our working groups. So we have 4 different working groups I'll mention in a minute. As you can see from the bullet there, several of the past workshops we've done video, or we have the presentation and various links to the presentations and discussions. So we're doing that again here today and tomorrow. So we're doing a video recording of the proceedings, and those will be made available online. So not just you guys, but everybody can benefit from the discussions and dialogue and information from these 2 days. So you guys sometimes, you guys have probably seen the news. So Lilium Aviation has about $100 million worth of investment. Volocopter also about the same. The last several years, people have been saying that Larry Page has invested something like that into Xci Aero and or Kitty Hawk. So that's 3 aircraft development programs that are on the order of $100 million apiece. There's now, on our website, evtol.news, there's more than 50 aircraft that are under development or under consideration, and they span everything from the silly to the serious, but it's not hard to come up with a number greater than $500 million as a notional estimate. As mentioned, so we started doing these, and we started planning this end of the first workshop was kind of end of 2013, beginning of 2014. Talking with Mark Moore, then when he was at NASA, convinced me that there really was a pony here, that there really was something incredible that was just on the cusp of being realized. So we had we started these workshops in 2014. In 2016, the end of 2016, at our fourth workshop, Nikhil Goel from Uber, we co-sponsored a reception, and they made a small announcement that they were very interested in this kind of design space. And then the white paper came out a few weeks later. AHS and I are listed in there as contributors, so I gave some editorial comments on it before it was released. And of course, the summit in April of 2017. And Mark, obviously, we'll talk more about Uber Elevate. You're going to talk about the summit. You got the summit in there. So there's another summit upcoming. And if you've been living under a rock and you didn't know any of this stuff, then they have this whole ecosystem where they're trying to connect all the pieces, to develop a whole ecosystem. So it's not just going to be enough to have the aircraft. You need to have skyports and working with how do you get the energy and the power, the real estate area, all the different parts to be able to realize this transformative capability. So in addition to the workshops and other technical events we have, so we do have the annual forum. So this coming year will be the 74th annual forum. It'll also be in Phoenix, so you can get your frequent flyer miles from coming to Phoenix. But if you're not familiar with the forum, it's going to be about 250 technical papers plus lots of special sessions, and I think we'll be doing probably 2 special sessions, so an entire day on electric VTOL. So on our website, vtol.org, so find out, make your plans today to go to the forum. All right. So in 1996, when I was in the JSF program office, I was working on the propulsion system development, and I was asked by Sam Wilson, then the NASA liaison to JSF, to take the old 1960s wheel of what was called the VTOL wheel of Misfortune and update it and modernize it and put the JSF concepts on there. So what this does is 45 different concepts. It tries to combine the vertical takeoff and landing capabilities of a helicopter with the high-speed forward flight of a fixed-wing aircraft, and we limited it to these ones to just aircraft that actually been built and tested. And I only have 3 representative examples of compound helicopters, but there's really been about 3 dozen compound helicopters. But the reason why it's called the Wheel of Misfortune is because most of them required either one engine or one propulsor, like a helicopter. So you only have one failure mechanism, or you needed lots of thrusters. Yeah, so you had to have some examples. The X22 quad tilt duct. It had 4 propellers and ducts. It had 4 engines. It had 25. One of them wasn't needed. It was only 1 engine out surplus, so it had 25% excess power. It had 11 gearboxes and all kinds of shafts, and it just made this really mechanically complex and expensive, and took up a lot of volume and weight and cost. And there's other examples. The XV3 lift fan system used gas-powered lift fan systems, so it used engine gas and distributed around the aircraft, and it took up half the volume of the aircraft with all the ducting and the piping and everything. So trying to get the mechanical or air power and thrust distributed around the aircraft was very, very difficult, and so you only had a few examples where it was decided that was worth the penalties. Having all that weight and complexity and cost and everything was worth the penalty. So we had the Harrier, which was 1 engine, so very simple. You had the Soviet Forager, the Yak-38, which was a Soviet design, so they were willing to live with whatever they could get. The V-22 took 50-some years to be developed, and it's doing God's work out in theater now, 400,000 flight hours. So doing fantastic work, but it's, it took 20-some years in development, had some early on, in the early days, had some accidents, and it is what it is. It didn't achieve all the early estimates for whatever design constraints were put on it, so it's constrained. Same thing with the F-35 now, also constrained by the requirements that it had. So the 20th century proved that vertical flight was possible with combustion engines, drive systems. The ASTOVL program, which led to JAS, proved that you could decouple the center of lift and the center of gravity from where the engine was. So you could have with the shaft, you could distribute that thrust around the center of gravity. So today, we have over 50 aircraft that are public, that people are working on designs for electric power. And so now that we have a sample size of more than 50, we can look at creating an electric VTOL wheel of fortune. And here's my initial breakdown, the hierarchy of how these things would be broken down. And there's a little write-up on each of these on our website, evtol.news. And there's further breakdowns that we'll probably develop, so it'll make more sense. But the interesting thing is, we started 2017 with, maybe half a dozen or so designs that were public or known about. And we ended the year with 52. Now, the hover bikes and things like hover seats and stuff like that, well, there's, we can keep adding those all day because anybody in his garage can take a bunch of, electric motors and make a flying lawn chair out of it. I had meant to put in a video, but in Germany, there was a group that put together a flying bathtub. Sorry, I didn't bring the video. So it really shows that that electric VTOL really is a transformative capability. You can make anything fly vertically, and there's enough power today that you can make a bathtub fly with a person in it. Probably a fiberglass bathtub, but still. This is a spreadsheet of all the different designs, and you can see that there's not that many cells that are filled in. We're going to try and flesh this out and add to our database. ABAB Data has talked about it a little bit in his presentation shortly, but this spreadsheet, the pieces of the table are printed in his report for his working group, which will be online. But we're really looking at, how do we, how is AHS as a vertical flight technical society, how do we, bring together the community? How do we get people aware that this isn't, a bunch of crazy flying car people? This is really serious, revolutionary, transformative capability. And so we're going to try to keep fleshing this out. And it's been about one aircraft per week that we've been adding. So unfortunately, we kind of have to do a time hack with the VTOL wheel and say, okay, well, as of the end of 2017, here's the wheel. And I don't know where we're going to do it in a year when there's 100 aircraft, so that'll be interesting. Okay, so electric helicopters, well, Sikorsky did it. They didn't fly the Firefly. Chris Van Buten, if you guys were here on Tuesday, showed all the stuff you took out of the helicopter when it wasn't a shaft-driven system anymore. But there's still a lot of complexity because of the cyclic and collective and the fact that it's a rotor and not a propeller. So when people came up with cars, they didn't make electric horses, right? That's right. They didn't make gas-powered horses, right? So they reinvented, the wheel. They reinvented the drive system. So that's not what we're talking about here. Yes, you can have electric helicopters. You can use the capabilities of electric power to do incredible things with rotor systems. But really, transformative vertical flight is more about distributed electric propulsion and the design freedoms that are capable, that are enabled by moving away from traditional single rotor helicopters. And there's a role for single rotor systems or rotorcraft systems with electric power, but it's not really the focus here of what we're mainly going to be talking about. Oops, sorry. So a little bit of history. So when Mark Moore was a crazy NASA harbinger, zealot, prophet, I don't know, visionary. So he did this ridiculous single-engine electric VTOL study, 2010, and then there was these crazy Germans that actually have the Guinness Book of World Record for the first, as they call it, it's called the first certified electric VTOL, electric vehicle contraption, whatever you want to call it, to get somebody off the ground. And for both of these, it's like, these people are crazy. This doesn't make any sense. What are they talking about? Well, that was 2010. You look a few years later when we started having our workshops. Okay, well, hey, now we're starting to look at things that are maybe make a little more sense. NASA's GL-10 Grease Lightning. 2014, they did tethered tests, and by the next year they did untethered tests, free flights, and transitions. So it's like, oh, wow, that's really interesting. And have a lot of data, which Colin Theodore mentioned that we're going to have that data available to the public within the next year, this year. So that's going to be pretty exciting stuff. Volocopter then started flying this VC-200 aircraft in 2013, first in a gym. They did tether tests, they did outside tether tests, and since, March of 2016, they did manned flight testing, and they haven't done a lot of manned testing. This was, for a while, the first and only one, but they've done a few other ones with passengers. At CES last week in Las Vegas, they had the CEO of Intel became one of the first passengers on the aircraft, and Intel's an investor in Volocopter. And that aircraft, they have over 500 flights. They've done some acoustic testing. And they now have several other aircraft that they've also built and have started testing. So we had them on the cover of Vertiflight. There's at the bottom, it's the 2X, which is their pre-production aircraft. So they've, as far as I can tell, they've built at least 3, and they've flown at least 1. So moving right along. Maybe I should go to this one here first. All right. So in 2011, after I just left DARPA, they hired Dr. Ashish Bagai, who is another crazy zealot who was doing this crazy thing called the VTOL X-plane that was looking at, how can you have really efficient hover and really efficient high-speed cruise. There was a competition. Aurora won that with a hybrid electric system. They're looking at 300 knots was the design speed, and I think 12,000. Is that right? 12,000 pounds. So big, really big. And they flew an all-electric subscale aircraft, 325 pounds, about a 20% scale. And then in April, when Uber announced had the Uber Elevate Summit, they revealed they'd done a quarter scale demonstrator, and they're working on, that's the quarter scale there in flight, and they're working on a 2-seater aircraft, and that's 800 pounds, right? 800 pounds empty. Yeah.
It's 850 loaded takeoff.
Okay. Okay, gross takeoff weight 850 pounds. I couldn't read the details on that spreadsheet I had back there. It was a little small. Lilium in Germany flew a full-scale demonstrator for the Lilium jet. And, it's just a really cool video, And those other companies that aren't revealing what they're doing, there's a number of other companies that are also flying full-scale aircraft. And after flying that and continuing to do research, they now have a 5-seat, you see up upper right, Lilium jet concept, which is actually very similar to the lightning strike design in many ways. And so many of these companies are looking. Darn. So many of these companies are looking at the Uber Elevate mission. Others are looking at competing systems where you can book a taxi or use it for electric, urban air mobility. But there's ones going from 1 seat to 2 seats. Xci Aircraft is looking at, I think it's 2 pilots plus 4 passengers, a total of 6 seats. They're looking at actually 1,000-mile range, so it's more of a regional, like a BizJet type of thing. And they are going to be building a demonstrator, a subscale demonstrator, and flying that next year. So electric VTOL or transformative vertical flight, it spans the whole spectrum from single seat to 6 seat and anything else, I guess 12,000 pounds, anything else in that broad spectrum. And so electric VTOL or transformative vertical flight is not synonymous with Uber Elevate. They're in the heart of the envelope where they think they can make the most money. But from a technology perspective or a technical perspective, it's the whole spectrum from small to large. Vahana, so AQ by Airbus here, the Silicon Valley part of Airbus, has been testing small-scale models of their Vahana concept, and we're going to hear more about that. So I won't steal the thunder. But very impressive work that they're doing. There's other companies. I don't know if this is going to work. There we go. That just do really great computer graphics. This is a concept in Dubai. So this is a 6-propeller tilt propeller and folding back the blade. So this is similar to the grease lightning concept. So like I said, so these concepts, we have everything, including, so this is Xci Robotic. So it's a British company, but they have a Dubai subsidiary that's looking at electric VTOL. Dubai is really incredibly all in on autonomy and electric. And so there's been a lot of stuff that's been going on in Dubai at some of their events. So, these guys don't know that much about, aircraft development or anything, but it's an interesting concept, and so we're tracking all these because we've seen with many companies or developers, their first designs when they're from 5 or 6 years ago are like, yeah, you guys need to learn something about aerodynamics and how things fly, and over the years they've really matured and changed. So it's neat seeing people learn. I don't think I have to say this to anybody here. So, the media is just, calls them flying cars. I think flying taxi or flying air taxi or something that's probably acceptable because I don't think we'll ever get them to say, they're a transformative vertical flight aircraft. Or I think eVTOL has really caught on. So electric VTOL, eVTOL, I think that seems to be, we're making some headway with that. So if it's a car, if it's an aircraft that can drive on the ground, then great, it's a flying car. But otherwise, it's not. So the only sense that you can say this like maybe a flying car is if like the Jetsons, it's something that's kind of personal, and you get in your flying electric VTOL or eVTOL aircraft. But anyway. So the agenda for the next 2 days. So today we're going to talk about the promise of electric VTOL and have some updates from some of the. I left it off there. Have the updates from some of the companies and developers on what's going on. Unfortunately, Brian Yudko from Aurora is not going to be able to be here, but Francesco Giannini is doing triple time, and he volunteered, or he was roped into, he was forced.
I think the term is voluntold.
Yes, he was voluntold to do the presentation, and of course, Brian didn't give him any slides, so he's done a little bit of hero's work here over the last couple of days, and he left his laptop in wherever it was. So anyway, he's my hero today. I did leave out, unfortunately, these are just the programmatic briefings. This is a workshop, and maybe, like I said, this may be the last time we call it a workshop, but we have 4 working groups. So one on private and recreational vehicles, kind of small eVTOL, then commercial intra-city, so kind of the Uber mission, then intercity, and then public services. So the different teams have been meeting over the last 6 months, and we talk a bit about where they are in their progress, their working groups. And we got a lot of great presentations. And during that working group discussion, we're going to want your guys' feedback and ideas, so it will be a little bit of a working discussion then. So then tomorrow it's all about challenges, okay? So, we're going to see all the great stuff today, and then it's like, oh man, well, what about noise, and what about the ground infrastructure, and what about the propulsion and airspace, and there's a little bit of, just to mix it up, a little bit of interspersing there with some panels, with some overview presentations on understanding more about what Uber is doing, and a plea from us and other professional societies is to get involved and help make this happen. So finally, I mentioned before the eVTOL.news. That's really the only URL you need to know, but we're Facebook and Twitter, and there's some links there for references to Uber's. The VTOL.org/transformative, which is way too long. We've got links to all the previous workshops, and there are the 4 roadmap working groups. So I appreciate your guys. Come on, stop. Attention there and help. Anyway, so the next speaker is going to be Mark Moore from Uber, and we're talking about the Uber Elevate Common Reference eVTOL. So you saw a little bit about this in the panel on Tuesday and a little bit last night at the dinner. But here's the details, the down low on the reference model. So